Hello everyone. We have already discussed about the superposition theorem and Thevenin's theorem. Now I am going to explain about the Norton's theorem. You already know that in Thevenin's theorem it states that the given circuit can be converted into a Thevenin's equivalent circuit. In that the Thevenin's voltage ETH in series with Thevenin's resistance RTH. Similarly, the Norton's theorem states in any two-terminal linear bilateral network consisting of energy sources and impedances can be replaced with equivalent circuit consisting of current source IN in parallel with an impedance Rn. The given circuit can be replaced by an Norton's equivalent circuit. It is consisting of current source IN in parallel with resistance Rn. Rn and IN are connected in parallel. How we can solve the given network using Norton's theorem? First, you remove the load resistor across which the Norton's equivalent circuit is to be found. Across which we want to calculate the Norton's circuit or Norton's current. You remove that load of the remaining two-terminal circuit. Mark the terminals of the remaining two-terminal circuit. Then the second point, calculate the current IN by finding the short circuit. To calculate the current IN, it's a short circuit current between the marked terminals. It is the same current that would be measured by an ammeter placed between the marked terminals. If you connect the ammeter, what current is flowing there, that same current is IN. And the third point is calculate the resistor Rn by first setting all the sources to 0. You already know that voltage source becomes 0 by short circuit and current source becomes 0 by open circuit, but not their internal impedances. And then finding the resultant resistance between the two marked terminals. And here Rn is nothing but RTH. Rn is Norton's resistance, that is equals to Thevenin's resistance RTH. The procedure and the value obtained using the approach described for Thevenin's theorem will determine the proper value of Rn. After that, you draw the Norton's equivalent circuit. Now we consider the simple problems. It is a given circuit. Here find the load current through and load voltage across resistor R2. R2 means this resistor. Across this resistor, you find the current flows through and voltage across this resistor by using Norton's theorem. Solution, and here you consider the step 4 ohms, 1 ohms, and here one resistor is there. You remove that resistor. This resistor is 2 ohms. These three resistors are connected with the 20 volt, 28 volt, and 7 volt power supplies. The first step is remove the load resistor and then short circuit point A and B. Here this is point A and this one is point B. You remove that 2 ohms resistor and you short circuit that, then the circuit becomes like this. Here the current is, one current is flowing in this direction, the another current is flowing in this direction. If you consider the current in this direction, in the upward direction, if you consider the current, if the current is in downward direction, then what it becomes, the current is flowing in the inward direction. This current is flowing in this direction and this current is flowing in this direction. Now we consider the current I1, I2 and IN. IN is short circuited current. The short circuited current, if you consider the short circuited current is flowing from point B to A, then I1 is flowing towards the left side and I2 is flowing towards the right side. How you calculate that current? Norton's equivalent current by applying Kirchhoff's voltage law to loop 1. Loop 1 means this one. Here you apply the KVL to the loop 1, then what it becomes? E1 is equal to R1 into I1. 28, that is the E1 voltage, is equal to 4 into the current I1. Therefore, I1 is equal to 28 divided by 4, that's equals to 7 amperes. Now the current equals to 7 amperes. This current becomes how much? 7 amperes. Similarly, you calculate I2 by applying the KVL to loop 2, second loop. What it becomes? E2 is equal to I2 into R2. E2 is 7 volt. I2, you don't know that value. R2 is equal to 1 ohms. Then what it becomes? 7 is equal to 1 into I2. Therefore, I2 is equal to 7 divided by 1. It becomes 7 amperes. You have already calculated the value of I1 and I2. Now, Norton's current IN is equal to I1 plus I2 because both are flowing in the same direction. In this upward direction we indicate that. So I1 and I2 are flowing in the upward directions. Then it becomes 7 plus 7 is equal to 14 amperes. This is a Norton's current. Then you calculate RN. RN by removing the load resistor and by short circuiting the voltage sources. If any current sources are there, then you reduce that current source by open circuit. Here both the energy sources are voltage sources. So you remove that voltage source and you short circuit that point, then the circuit becomes like this, and the total Norton's resistance Rn is equal to, here these two resistors are connected in what? Parallel. So it becomes R1 into R2 divided by R1 plus R2, that's equals to 4 into 1 divided by 4 plus 1, it becomes 0.8 ohms. Now, Norton's equivalent circuit. This indicates what? Norton's equivalent circuit. That is, IN and RN are connected in parallel. IN is 14 amperes and RN is 0.8 ohms. These two are connected in parallel, and across with that we have the load resistor RL also. So that the load current IL is equal to IN into RN divided by Rn plus R2. IL is the current flowing through the load resistor. This current is calculated by IN into Rn divided by the total resistance Rn plus R2. 14 into 0.8 divided by 0.8 plus 2. This becomes 4 amperes. Then voltage across resistor R2 is equals to VR2. It is nothing but load voltage drop. Across load what voltage is drops, that is calculated by VR2, that's equals to VL is equal to load current into load resistor IL into RL, that is 4 into 2 is equal to 8 volts. That voltage equals to how much? 8 volts. Example 2, find the current through RL using Norton's theorem from this circuit. Here we have the two resistors R1 and R3, and here we have one resistor, that is 15 ohms. E1 and E2 are voltage sources, 100 volt and 180 volt. Value, and if you have any doubts you can ask in the discussion class also. Thank you.